Hey Measuring Hero, Jay here. A few episodes ago we talked high level about the medical industry with Michael. Today I thought we would go a little deeper in an example of one of the challenges, in particular this femoral knee here. In order to do so, I thought we'd bring in one of my good friends, Luis, who we know, we met each other actually we worked together back in Maple Grove. So before we begin, Luis, do you want to introduce yourself?
Of course, thanks Jay. It's a pleasure to be here with you. My name is Luis Hernandez, and originally from the US, from Zeiss US, and now I'm a transplant here in Germany as part of the Medical Global Applications team. And I'm actually super excited to have this shared exciting experience with you on explaining the femoral knee.
Awesome. We appreciate having you here because as everyone's aware, I'm not really good at explaining really super detailed stuff. So, okay. Michael talked to us about the challenges around making this knee. Can you go into what the challenges are on measuring this?
Yes, so just as hard as it is to make it, it's just as hard to measure it. And I personally think it's a little bit harder. The reason it's a little bit harder, I think, is because we have to measure the inside, which is normal, right? Normal processing. And then we have to flip it around, and now we have to measure this contour, the actual surface of the femoral knee that's going to be rubbing against the other implant, this other plastic implant. And so this needs to be perfectly smooth and needs to stay perfectly smooth the whole time. Why do I say that? And so I say that because when we're measuring, even if we're doing a light touch, what can happen is we can create micro scratches on occasion, right? And we want to avoid this. We want it to be pristine. So we just can't touch it. So it's super hard.
So the challenge is, of course, it's extremely shiny, it's free form, and you can't touch it. That sounds really challenging. All right, Luis, well, good luck. How do we do it?
Right, so our solution, and you might have been familiar with this because you're so familiar with the O-Inspect, is we use the DOT scan, but there's a little twist to this DOT scan, and that twist is that we can actually rotate it in 2 degrees, or in 2 axes. So we can reach almost any angle that we need to on the femoral knee. And it's also, as you know, non-contact, and that's how we actually overcome the difficulty of not being able to touch this, so we don't risk micro scratches. And if I may, I'll just here show you real quick. So as you can see here, we can start measuring it, and it's non-contact. We stay a couple centimeters away from the surface, but we get to keep the accuracy, right? So our job here is to measure this without touching it and keep the accuracy. But we get a bonus because the DOT scan can actually scan much faster than a tactile sensor. And if you keep looking, maybe you'll notice this at the bottom here, big old rotary table. And so we actually use this so that we can essentially use it as a 4th axis to scan the entire contour of that freeform surface on the implant.
Got it. So what I'm hearing is in order to keep it non-contact, we use the DOT scan sensor, which is a great technology. We've actually gone into the technology before. But because we've gone non-contact, we can integrate a 4th axis rotary table, which gives us the ability to do it really fast.
Right, perfectly summarized.
Awesome. Well, okay, well, that seems pretty straightforward, at least for us. So thanks, Luis, for showing this to us. Appreciate it.
Thanks for having me, Jay.
It's good to see you again, my friend.
Always.
All right, and with that, I will thank you for joining us, and we hope you continue to stay safe and stay healthy, and hopefully we'll see you next Thursday.